Welcome to this week's math lesson. So we're continuing on with our transformational geometry, and today, this week, we are talking about reflection right here. So to start off with, what is a reflection in math? So it's a flip of a figure. So last time we talked about a slide, this time we're talking about a flip. And we use a specified line. So I'll show you shortly in this video how we can use the different lines on the grid to help us reflect shapes from one quadrant to another. Okay, so before we get there, let's talk about reflections we see in real life. So you can see some of my examples here. We have reflections in water where we have this beautiful mountain range and the trees reflected along the shoreline, right? So there's our line of reflection right in the middle. Okay, we also have mirrors. So obviously you probably get ready in the morning and look at yourself in the mirror, right? And then we have reflective surfaces. So this is called the bean. It's in Chicago. And it is literally, it looks like a giant kidney bean. It's like a big sculpture and it's reflective and you can take pictures in it and you can see the reflection there. Now, before we move on to talking about how we reflect a shape, what happens to an object when it's reflected? So let's look at the lake, for example. Is it exactly the same as it was? I mean, it's pretty close. Could we fold it in half along that line and have it pretty symmetrical? Absolutely. But if we turned that picture, would it be exactly the same? Well, it's turned, it's changed. The shape isn't exactly the way it was. Just like when you look in the mirror or try to take a selfie in a mirror, your hands become opposites and your sides become opposites. So how do you reflect a shape when we're using our geometry thinking? Well, what we're going to do in this demonstration is I'm going to reflect our shape over the y. I'm going to reflect it over our vertical axis here, okay? So let me change pen colors quickly. So let's follow along with our steps here. So it says A, ensure that the points of the figure are clearly labeled. This just helps you keep track of things. So we'll label our top point of our shape A, this side B, and this side C. Right. We're good on that one. A is done. Measure or count the distance from the points to the line of reflection. So I've drawn our line of reflection on this one. It is the red line. So our C point is how many away? 1, 2, 3. Okay. So C is 3 away. I'll come back and do the other points in just a second. So now we're going to go the same distance, but the opposite direction, right? So how many was C away? It was 3. 1, 2, 3. So this is also going to be C, but because it's the image and not the pre-image, as we learned last week, we have to put a little 1 to show it's our copy. Okay, so let's go back and do our other points now. I'm going to change color so we can see B really clearly. So B point is 1, 2, 3, 4, 5, 6, 7 away. All right then. So then we can count from that same point. 1, 2, 3, 4, 5, 6, 7. So that's our B1. Okay. And then we'll head up to A. A is how many away from the line of reflection? 1, 2, 3, 4, 5. So when we reflect it over, we go 1, 2, 3, 4, 5. So that's our A1. Now I've skipped ahead a little just by pre-labeling, right? So I'm labeling my new points and I've placed them all. So I've got that part done. So now I can connect my reflected points. Pardon me. So my A touches my C over here, my B and A connect, and then my C and A connect. So by reflecting that across, we could fold it, if it was a piece of paper, along this red line here, and they would exactly match up. Okay? So let's talk about some of the ways that we can reflect shapes around our Cartesian plane. So what are all the ways that we can reflect figures around this grid? So in this part, I'm going to show you the 2 basics, and then if you want a little more of a challenge, you can stick with me for this bit, or if not, you can move forward, but stick with me for the basics. So one of the ways we can do is across the x-axis. we know which axis is the x-axis. It's this one. It's our across. So what we can do is use that same technique where we counted. Now our C point is 1 away from our line of reflection, and so is our D point. So we can literally just replace those down here, right? And then we had how many bumps away for our A? From our line goes 1, 2, 3, 4, 5 away. So then we go the same. 1, 2, 3, 4, 5 away. And the B is right across from that, which this particular shape is pretty easy to roll over as long as you're making sure you line up a little bit, right? And then we can reconnect those points that we've now reflected over that x-axis, okay? We can also, as you saw, as I demonstrated a couple of seconds ago, go across the y-axis. Oh, that was the one I wanted. Go across the y-axis. There we go. And our y is our up and down. It's our vertical axis. So in this case, we can count from our B across. 1, 2, 3, 4. Okay, and it goes 1, 2, 3, 4 to here. Yep. Oops, I forgot to connect that guy. There we go. And then our D is also 1, 2, 3, 4 cross. 1, 2, 3, 4. So that guy becomes, and then from there we don't even have to really count. We can just use the original shape, our pre-image, right? So C and D were 2 apart. So I can say, right, 1, 2. So then my C1 belongs here, and B and A are 1, 2 apart. So I can go over here. Now if I connect all of this business together, our new image over here is also a reflection, okay? So that's the basics. Now, if you want to stick around and figure out how we can go across in a different way, please feel free. If you're ready to move on to the next bit, you can totally do that as well. Okay, so here's the extension. What we can do is we can actually reflect shapes across a diagonal line. Okay, so let's start with y equals x. That's our y equals x line, and it should cross through our 0, 0 here, but it goes diagonally across from our right to our left side. Okay, so if we had a figure here, let's have it connect here at 0, 0. We'll just keep it real simple. We'll draw a square. Right, well, we're going to reflect this across the y equals x line, which is that yellow line that I have just drawn. Where do you think it's going to end up? Well, this point, the 0, 0, is going to stay the same, right? So we could go up 3. Let's change colors so we can show our pre-image or image here. So from on our original here, we have 3 down. 1, 2, 3. 3 across. Right? So we can also do things across diagonally. Now it's a little trickier when your figure is not touching, and it's hard for me to teach you without being in front of you, but this gives you the kind of basic idea. Okay, and last but not least, we can do the y negative x line. So this one is also diagonal, and it goes this way across. It just goes the opposite way to the one we just talked about. Okay, and we can do the exact same thing, right, where we reflect across that diagonal. As I said, I really want you to focus on the basics, but this is just to get you thinking a little bit and hopefully extending your ideas. Okay, so here's another little demonstration. In this one, I really want to focus on tracking how our coordinate pairs shift as we reflect a figure. So what we're going to start with is our pre-image, which is our red guy right here. We'll just put a little PI in here to remind us that he's our pre-image. Now, if we reflect this figure across the y-axis, so we're going to reflect it across this line in the middle. Let's see, have a color that everybody can see. How about that, Missy? Right? If we reflect it across the y-axis, what will our new coordinates be? So let's write down what they are right now. So point A is at -8 across and 7 up. So -8 and 7. Point B is at -3 and 7. C is at -8 and 3. And D will also be at -3 and 3. Okay, so let's flip it over and see what happens, shall we? So, how far away is D? 1, 2, 3. It's 3 away. So 1, 2, 3 over here. So we have to make sure we label that to show that it's our copy. Yep. Okay. So now we can say right. We can also do B. 1, 2, 3 away. 1, 2, 3 away from the line. Okay, and there's our B one. Okay, and then we can use the rest of our figure to just count the difference we need to add on. So we know there's 3, 4, 5, 6, 7, 8. Okay, so that's another 5. 1, 2, 3, 4, 5. Okay, so there's our A copy. And our C would also be that, so we'll make sure it's all lined up here. There we are. So let's draw in the lines of our image now. Okay. So it looks like we did a good job. It looks right. Let's check out what we've got with our new coordinates. So our A point is now at 8 across and 7 up. Okay, our B point is now at 3 across and 7 up. And our C point, 8 across, 3 up. Our D point, 3 across, 3 up. Okay, so let's compare now. So the actual numbers are the same, but we've gone from a negative X and positive Y quadrant to a positive quadrant. So now all of our pairs are both positive numbers. Okay, so let's try the same figure. If we translate it, if we flip it over and reflect it, I swear to God I'm awake, reflect it over the y-axis, okay, or the x-axis. Oh, my days. This rainy weather is not doing me any favors, folks. Okay, so here we go. We'll start with C and D, shall we? Because that's closest to our axis. So how many spots away have we got here? 1, 2, 3. Cool. We go 1, 2, 3 the other way. So we'll actually mark that as a 2. We already have 1 reflection over here. So let's make sure we're marking this really clearly. Okay. And our D is also 1, 2, 3 away. 1, 2, 3. So there's our other one. Okay. Now our A and our B if we're going from D, let's say, how far away is B? 1, 2, 3, 4. Okay. So we can just count up another 1, 2, 3, 4. So that's our B2. And then our A will be on the same across and line up with that C. Okay. Here we go. Okay, so we have these same originals for our, right? We had -8, 7. We can just copy from the table above. -3, 7. We have negative 8, 3, and negative 3, 3. Okay. So now we have an image that we flipped over the x-axis. What are our new coordinates? So our A is at negative 8 across, and it is at negative 7. Okay, and our B point is at negative 3 across and negative 7 down. Our C point is at negative 8 across and negative 3 down. And our D point is at negative 3 across and negative 3 down. So similar to what we did up in the first thing, now we can see we've reflected that shape into the quadrant that has negative, negative, right? Okay. All right, so the last thing for this lesson is that we're going to reflect a figure, which I need to draw here. We're going to reflect a figure over a specific line. So instead of using X and Y, we can use specific lines on our grid. So let's start here by adding our figure. Okay, so let's draw a triangle over here. Let's make it kind of small so we make it kind of easy. We don't overcomplicate. So there's our figure. So let's start here. We're going to reflect across the line x equals negative 2. So what that means is we're going to find the negative 2 on the x, right? Literally what it says, x, negative 2, go and find it. Where is that? It is right here. Hello. There's our line. So then we can just say, okay, this is our line of reflection. This is where we're going to reflect our shape over. So now we can do our normal thing. We can count across and see how many away it's going to be, right? So let's A, B, and C this. Okay, so our A point is closest. So we go 1, 2, 3, 4, 5. Excellent. 1, whoa, wonky 1. 1, 2, 3, 4, and 5. Okay, so that's our copy. There's our A1. Okay, and B was 2 away from that. We can just place that sucker right there. And then C is how many up? 1, 2, 3 in the middle between them. So that's 1, 2, 3. Let's connect those lines up and show us off our new reflected shape. Okay. All right, so instead of using the y-axis, I still did a vertical reflection, but this time I used the x equals 2 line, okay? So now what we're gonna do is we're gonna reflect it over the y equals 3. Well, I'm gonna redraw it, but we will do it in just 1 second here. All right, brand new figure. So here we're gonna go over the line y equals 3. So where's 3 on the y? It's right here. So this is our line of reflection for this figure. Okay. So let's figure it out. Our B and our C are closest, so let's count. 1, 2, and 1, 2. So how far is it going to be away on the other side? It's going to be up 1, 2, and 1, 2. So there's our C point, our C copy, and our B copy. Okay, between B and A, we have 1, 2, 3, 4. So we go 1, 2, 3, 4. There's our A, copy, and then we know it's also going to be 4 over here. 1, 2, 3, 4 for our D copy. Now, we have to do this little jutty-outy thing I drew here, which is only 1 away. So that belongs right there. So now, when we connect all of our reflected points, yeah, unfortunately I can't talk and draw lines at the same time. So there we are, reflected over our line of y equals 3. All right, so I'm gonna send you off to go and do some practicing online. Let me know if you have any problems. Don't forget, office hours, Tuesday, Thursday, 1 o'clock to 3 o'clock p.m. on Google Meet. Math help, Wednesday morning, 10 to 11 on Google Meet. Come and hang out if you need help. Please and thank you. Have a great day.